So for question 23, it's a box and whisker diagram. In the actual question, we didn't have this whisker at the end here. So we have to work out what that was. So the scores are shown in the box plot, but the box plot is incomplete. So this bit wasn't here. So the range of scores is 25 more than the interquartile range. This sentence here is more important for this question. So it says, use this information to complete the box plot. Now, we have to find, it's talking about interquartile range in this sentence. So we have to find the interquartile range. Now, the interquartile range is the upper quartile take away the lower quartile. The upper quartile in this box is the end of the right-hand side of that. So you can see that the end part of this is the upper quartile. So we take a value here, and this one here is your lower quartile. So this one here is basically take a value of that. And that would be like 30, if you take those two away, the upper quartile and the lower quartile, if you take those two values away, you should get 13. Now in this sentence here, it says the range of scores is 25 more than the interquartile range. So what you do is you take the interquartile range and you add 25, which is 38. Now this becomes the actual range of this. So the range is the maximum value, take away the minimum value. So that's where the lines at the end come in, the whiskers. So if to complete this, remember this is disappeared. So if it's between the maximum and minimum, we can find out that if we find out that it's 10 is the actual minimum of this, we can add 38 to get the maximum value. So when we get that, we can draw a line down here and draw this whisker of that. So that would end up being 48 here. So it says explain why the interquartile range may be a better measure of spread for this distribution than the range. So range may be affected by an extreme high or low value. So this one is more contained, the median. Whereas if you had an extreme value, this whisker could go on and on and on. So, and it wouldn't be accurate for the whole data. So the actual interquartile range would be actually more reliable. So Kevin scored 32 marks in the test. What percentage of the class scored lower than Kevin? Now the way you look at it is, from this whisker here, that's 25% of the data. In this box, the first part of this box is another 25% of the data. And in the second box, it's another 25% of the data. The end bit is another 25%, but Kevin, I think, was 32. So it's this point here. You can see that it's 25, 25, and 25, which is 75% of the class scored lower than Kevin. Question 24. A survey was carried out to estimate how many people own a smartphone. The results of the sample are shown below. So do own a smartphone is 236 and do not own a smartphone is 64. So based on this sample, estimate the number of people in a town with a population of 15,000 who might own a smartphone. So the way you would do this is you take your 236 and it's out of 300 when you add this up. So that's the small portion. And you times it by the 15,000 of population. So you're estimating that it would be 11,800 who might own a smartphone in the population. So the sample data was obtained by a group of 17-year-olds. Do you think your result in A is of an overestimate or an underestimate for the number of people in the town who own a smartphone? Explain your reasoning. So this one's an overestimate. Now that's because sample data was obtained by a group of 17-year-olds. So the population among 17-year-olds is likely to be higher than any other age group. So it might give you a false reading when you do your surveys. Okay, we've got algebraic fractions for 25. So there's many different ways of doing this. I'm going to show you one way of doing it. Okay, but as I said, there's many different ways you could do this one. So you can see this one here. What we want is a common denominator of each fraction there. So we can get you'll see 5, 3 and 3. So the common denominator would be 15. But if you have to adjust the bottom, you have to adjust the top. So times them by 3 to get 15 in the first fraction. You have to times it by 3 on the top. So the way we do that is cover the expression with the brackets and put a 3 outside that. So that just means 3 times this whole expression. Then we do the second fraction, we times that by 5. So we have to times the top one by 5. And that's what we've got here. 5 brackets 4x plus 5. The last part of it on the other side of the equation is we've multiplied the bottom by 5. So we have to multiply the top by 5, which then becomes 100. So 20 times 5 is 100. Because we've got the whole equation under the same common denominator, we can cancel those down. And we can just work with the top part of the fraction. So we can bring that and put it down here. So this is the top part of the fraction. So it's 3 brackets 2x minus 1 plus 5 and 4x plus 5 and then equals 100. Next step is we expand the brackets. So 3 times 2x is 6x, 3 times minus 1 is 3, 5 times 4x is 20x, 5 times 5 is 25, and that's equal to 100. Next one is we simplify it by collecting our like terms. So we can see 6x and plus 20x, so when we add them two together it's 26x, and minus 3 plus 25 is plus 22. And that should be equal to 100. We take away 22 from both sides. So that means we're left with 26x on the left hand side, and it's 100 take away 22, which is 78. Next step is we divide both sides by 26. So we're left with x on the left hand side, but 78 divided by 26 is 3. So x is equal to 3. Question 26, it says the value of John's house has risen by 3.5%. It is now worth 150,075. What was the original value of John's house? First step there is you add your percentages. So you start with 100% and we add 3.5%, which then becomes 103.5%. Next step is we equal it to the actual where it's now worth. This is because the value of John's house has risen by 3.5%. So now it's become 103.5% and it's equal to 150,075. Now to work this out, we can put it down to 1%. So we have to divide each side by 103.5. You can see there 150,075 divided by 103.5 and we have 1,450. The next we have to get it to 100%. Which is basically, we just times 1,450 by 100, which then becomes 145,000. So it started off at 145,000, it risen by 3.5% to get 150,075. So the answer, the original value would be £145,000. Question 27 says expand and simplify. So it's double brackets. So if we look at this one here, to get 6x, so 6x squared, you're multiplying 2x times 3x, which is 6x squared. To get 4x here, we're timesing 2x times 2, which is 4x. To get minus 15x, we're multiplying by minus 5 times 3x, which is minus 15x, and we times with minus 5 times 2 to get minus 10. That's as it expanded the brackets, and now we need to simplify it. So to simplify it, we have to collect our like terms. So 6x squared stays where it is, and we collect the 4x and the minus 15x. So what's 4x take away 15x would be a minus 11x. And minus 10 stays where it is. So we've got 6x squared, take away 11x, take away 10. That would be your final answer to that. That's expanded and simplified. So to simplify question B, we have to factorise these things and then cancel down. So the top one there it's got a square here with a takeaway and then a square number there. So this is a difference of squares at the top. So factorising that would be x plus 7 and x minus 7. Now for this bottom one, it's just with a 1 bracket. So we're looking at 2 and 14. What goes into 2 and 14 is 2. The highest factor of that would be 2. And 2 times x is 2x, 2 times 7 is 14. So x minus 7 would be in the bracket. Now when you look at it now, you can cancel down. You can see in the brackets here x minus 7 and x minus 7. So we can cancel these two down. And what we're left with is x plus 7 over 2. And that should be your final answer for this one. So for question 5, this is an elevations question. So a solid is made from 1 centimetre cubes. On the grid below, draw the side elevation of the solid. So this is from the perspective of you standing next to this shape and looking towards it. What do you actually see? You would see 1, 2, 3 at the bottom, 2 in the middle and 1 at the top, and I've drawn it there in